I did find a mistake that I made on my previous video. On example 4, for some reason I wrote down 0.001 for the denominator. I don't know why I did that. So if you can fix that for me, and I should have noticed it, so I'm sorry. As h gets really close to 0, the difference quotient, the simplified difference quotient should have been approaching 10. And this number, when I had that mistake, was 100 point something. So I should have noticed something was wrong. But now I looked at it. I was like, okay, that was a silly mistake. So if you can change your note, it should have been 0.01. And if you divide it, the correct answer should be 10.01. But in this video, I'm going to go over 2 of more advanced examples. These are a little bit more challenging. Example 7 and example 8. I may need the whole room for example 7, so I will create another page for example 8. Hey, what was that? It's crooked. Hey, it's getting crooked again. I just want to enlarge this. I guess I can't really enlarge this, huh? All right, that's fine. That's fine. I'll do example 7 right here. All right, for f of x equals 3 over x squared. That's an odd-looking rational function. Find the difference quotient, a simplified form of the difference quotient. So write down the difference quotient. That's the formula. Let's plug in this x plus h into x to find what f of x plus h is, okay? So the first thing on top of the fraction will be 3 over x plus h squared, okay? Minus, I need to subtract f of x, which is simply 3 over x squared, and I'm dividing all of them by h, okay? I'm going to divide all of them by h. On the numerator, we need to focus on the numerator now. We are subtracting 2 rational expressions. So what they need a common denominator, right? So I'm going to go ahead and write down the original fractions right now next to each other like this. And then let's figure out the common denominators. The second fraction has x squared as the denominator. So what I'm going to do is I'm going to multiply x squared to the top and bottom of the first fraction, okay? The second fraction only has x squared. So what I'm going to do is I'm going to copy down x plus h squared on top and bottom. And voila, now they have a common denominator, right? Okay, once I'm done subtracting and writing this as a single rational expression, I was going to divide them by h. But dividing a fraction by h will look kind of ugly. I will have a fraction in a fraction. So instead of dividing by h, how about I write it as multiplying it by 1 over h? Because you know, dividing by 2 is same as multiplying by 1/2. So instead of saying I'm going to divide everything by h, I will say I will multiply by 1 over h. Okay, let me go ahead and put the numerators together. Let's put the numerators together. 3x squared minus that term. I will have 3x squared minus 3 times. And what is x plus h squared? We know that is x squared plus 2xh plus h squared. We FOILed this out previously. And all over, let's just write down that denominator once. I will simplify the numerator. And when I'm done, I will multiply that by 1 over h. Okay? Let me see. I may try to... I'm going to get rid of number 8 for right now. Okay. And I will just continue working on example 7. This one takes a little more room here. 3... Oh, that's too big. 3x squared. And then if I distribute the negative 3, I will get minus 3x squared minus 6xh minus 3h squared and all over x squared, x plus h squared. Okay, put them back in a nice bracket, and that 1 over h is still waiting. All right, anything cancels out? I have a 3x squared. Why wouldn't it write? And I have a 3x squared. So those will cancel out and will just leave me with negative 6xh minus 3h squared all over x squared times x plus h squared. And I'm almost done, you guys. We're almost done. Notice that the numerator both have h's, right? So what I will do is I will factor out that h in front of it. H is in front, and I will have negative 6x minus 3h all over x squared times x plus h squared. And we're going to multiply this by 1 over h. Why did I pull out the h? Because I wanted to do this. I wanted to cancel out that h. Cancel, cancel. So we have a final answer now. The final answer is negative 6x minus 3h over x squared times x plus h squared. Why would I ever need to figure out a difference quotient of such a weird-looking rational function? I mean, I think it's a good practice, don't you think? It's a good algebra practice. It made us review how to write common denominators, how to subtract rational expressions, and how to simplify all these things. You know, just good algebra practice. But I don't think I'm going to go all this much on your first exam. I mean, probably just try to keep it as a quadratic function on your exam 1. But let's do one more advanced example. Example number 8, okay? For f of x equals square root of 2x, find a simplified form of the difference quotient. So we know the difference quotient is f of x plus h minus f of x divided by h. So if I plug in x plus h into this x, I will get square root of 2 times x plus h minus 1. That is f of x plus h. And then I need to write down minus f of x. So let's do minus square root of 2x minus 1 all over what? All over h. Now we got the difference quotient, but we are going to simplify this a little bit further. I'm going to distribute the inside of this real quick. 2x plus 2h minus 1. Doesn't really make much difference, but I just wanted to distribute it. All right, what you are now going to do is in 1.4, I mean, we should know why we need to go further. We need to go further because we can't have we can't have h in the denominator. Okay, we can't have, because eventually what we're going to try to do is we're going to plug in h equals 0. And if h is the only thing that's in the bottom of the fraction, the denominator will become 0. So what we will do is something a little different. We usually rationalize the denominator, but what we are now going to do is we're going to multiply the top and bottom by the conjugate of the numerator. Oh, odd, right? So look, what I'm going to do is I'm going to multiply the numerator and the denominator by this. Square root of 2x plus 2h minus 1. You've seen that guy before. Plus square root of 2x minus 1. Okay, this, what I just wrote down, is a conjugate for the original numerator. But if you're multiplying that to the numerator, you need to multiply the same thing to the denominator. So you just write it exactly the same, right? The copy of it, okay? Now, why are we doing this? Have you seen this, guys? Take a look. If you have a plus b times a minus b, if you're multiplying that, what will happen? You're going to have a squared. Also, you're going to have minus ab, right? And next term will be plus ab, plus ba, but we can switch a and b. And lastly, minus b squared. So that will simplify to a squared minus b squared. The middle terms cancel out. That's what we're trying to do. So if you are squaring, if you are multiplying a plus b times a minus b, a lot of things will cancel out. So take a look. Treat this as your a and treat this as your b. We are really looking at a minus b times a plus b. So when I multiply them, the numerator will get a squared. A squared is if a is 2x plus 2h minus 1, a squared will be square of that, so it's just going to be the radicand coming right out. So I will have 2x plus 2h minus 1 coming right out. And then what do I need? I need the minus sign after that. Now I'm looking, I just did a squared. We wrote down the minus sign. I need the b squared. If b is equal to square root of 2x minus 1, b squared is simply the radicand coming out. 2x minus 1. 2x minus 1. All over h times, I will have to just write the expression down here. Let me go ahead and write that down. The bottom, we can't really do much. We just have to write it down. All right, let's keep going. All right, hold on, I'll move these down. Okay, we should be able to simplify the numerator a little further. 2x plus 2h minus 1. If I distribute the negative sign, I will get minus 2x plus 1 all over h times 2x plus 2h minus 1 plus 2x minus 1. Okay? And you're like, where are we going with this? Oh, you'll see, don't worry. The 2x will cancel out, right? Positive 2x and negative 2x. What else cancels out? The negative 1 and the positive 1 cancels out. The only thing that's left is 2h. And guess what? If it's just 2h left on the numerator, there was that h in front of this long conjugate factor. We can cross out this h. So finally, your answer is 2 over square root of 2x plus 2h minus 1 plus square root of 2x minus 1. Voila, we're done. So we're happy now because we don't have single h in the denominator. Even if I plug in h equals 0, there, we're going to still have something other than 0. So that's what we had to do. I didn't want to do this example, but I saw one on your homework, and we copied the homework from the 261 template. So I wanted to include an example similar to this. But I'm not saying this is easy. This is very challenging. So if you need me to go over another example or just go a little bit slower, I can do that. Okay, because they were very challenging. But use a note. Feel free to watch this over and over again. But you should be able to start working on homework 1.3. And I will see you guys next